Hello everyone, welcome to the introduction of the RF test tool. First, the main function of RF test tool is to verify chip's output power, receiver sensitivity, frequency offset, modulation characteristics and other important key parameters. And the RF test tool supports two protocol standards, Bluetooth Low Energy standards and IEEE 802.15.4 standards. Second, the RF test tool is usually used for performance verification and quality control before mass production. Additionally, FCC, BQB, CE, SRRC, KC, and other laboratory certifications can use this tool to assist in testing. RF test tool has two versions. The old version of RTL8762X RF test tool is used for RTL8762C8762D and 8762E series, and the new version of RF test tool is used for the RTL8752H, 8762G, 877XG series N, including the new BLE SoC series. Both versions of the RF test tool use the standard HCI command format. The difference is that the new version of RF test tool supports more testing and setting functions, and the new BLE SoC series chips will use this version. This page introduces BLE signaling test, direct test mode. Signaling test does not require using the RF test tool, but only requires direct connection to a signaling tester, such as Anritsu 8852B, for testing. We support two methods. 1. Over HCI interface, just need to ensure the DUT is in MP mode. 2. Two-wire UART interface, this mode need to burn the test app and work in normal mode. This is the connection diagram using the RF test tool. You need a PC and an RF tester. The DUT is connected to the computer via UART, and the RF tester can be connected to the computer via UART, LAN, GPIB or other interfaces. In addition, the DUT and the tester's RF port are connected with an RF cable or other antenna to ensure that the signal can be received. Before using RF test tool, you must first burn the test images and enter MP RF test mode. Users can use MP tool to configure the MP mode in the config setting, and then burn the generated configuration file together with other test images. The new version RF test tool is for the RTL8752H, 8762G, 877XG and the new BLE SoC series. Supports Bluetooth Low Energy standards and IEEE 802.15.4 standards. The main blocks are as follows. UART interface, and the baud rate is 115,200 bps. Main function, main test function page, including single tone, BLE, Zigbee, etc. Frequency offset calibration, manual frequency offset adjustment. Log message, can check whether each step is executed successfully or not. Hotkey, set or get some chip information. LBT, adaptivity, anti-interference test, used for certification. This is the old version for RTL8762C, 8762D, 8762E series, and only supports the BLE standards. The main blocks are as follows. Download mode, burn the common test images required for RF testing. Users can also use MP tool to burn the test images. RF test mode, for RF test. UART interface, and the baud rate is 115,200 bps. Main function, main test function, including single tone, BLE, etc. Frequency offset calibration, manual frequency offset adjustment. Log message. LBT, adaptivity, anti-interference test, used for certification. This page introduces the download mode of the RTL8762X RF test tool. Users can use this function to burn the general test images. Before burning, P03 must be grounded, and the steps as below. 1. Select the correct IC type. 2. Switch to download mode. 3. Click the detect button and select the COM port, and no need to open the serial port. 4. Click download to start downloading. When the message task executed successfully appears, it means the download is successful. Then make sure P03 is disconnected and restart the device. And then you can use the RTL8762X RF test tool. This is a comparison of the test functions of the two versions of the RF test tool. Both versions support BLE single-tone LE continuous transmission hopping LBT frequency offset calibration test functions. But the RF test tool also supports Zigbee BR-EDR and transmission power setting functions. However, the current BLE SoC series chips do not support BR-EDR. The same test items are set in the same way in both versions. The following will introduce each test item using the RF test tool. LBT adaptivity. This function is used for CE and SRRC certification anti-interference avoidance test. And the CE specification only needs to be supported when EIRP greater than 10 dBm. The parameters as follows. LBT enable. Enable LBT function or not. No TX mode. If LBT is enabled, the device will stop transmission. Please select this mode during certification. Reduce TX mode. If LBT is enabled, the device will reduce transmission power, and it's just an option for users. LBT and gain. Gain value of the antenna. LBT threshold. Used to set the threshold for LBT activation. LBT will be triggered when target power plus gain threshold. Single tone is the single carrier signal. Can be used to adjust frequency offset, detect spurious signals, etc. The steps are as follows. 1. Select single tone. 2. Choose channel. 3. Click start button and start to test. 4. After testing, click stop button. Manual frequency offset calibration. The current BLE SoC series chips only requires frequency offset calibration, which can improve communication quality and ensure compliance with BLE standard specifications. The calibration steps are as follows. 1. Start the single-tone signal. 2. Set crystal cap value. 3. Click Set. 4. Use the RF tester to measure the frequency offset. 5. Reset the crystal cap value until the measured frequency offset is within the range. 6. Click Save to Device to save the crystal cap value to the device. LE Continue Transmission. The duty cycle is 100%, which is used for certain laboratory certification tests. The steps are as follows. 1. Select LE Continue Transmission. 2. Choose channel. 3. Choose packet type. 4. Choose payload type. 5. Set TX packet count. 0 means infinity. 6. Click start button and start to test. 7. After testing, click stop button. BLE transmit test. This can be used to test output power, carrier frequency offset and drift, modulation characteristics, etc. The steps are as follows. 1. Choose LE packet transmit for MP. 2. Set the BLE parameters. 3. Click start button and start to test. 4. After testing, click stop button. This is the parameter of BLE spec, and during the transmit test, when the payload is set to 11110000, delta F1 can be measured, and when it is set to 10101010, delta F2 can be measured. BLE receive test. usually used to test PER. The steps are as follows. 1. Choose LE packet receive, 4 MP. 2. Choose channel and PHY. 3. Click Start button and start receiving mode. For after testing, click Stop button. And the green box will show the number of received packets and our SSI value. Hopping test is used for some laboratory certifications such as FCC, CE, KC, BQB, and mainly used to test dwell time and band edge. Start channel, default 0. Stop channel, default 39. This page configures temporary transmit power settings. These settings depend on the chip. For example, if the chip does not support BREDR, max transmit power of legacy 1 Mbps, 2 Mbps, 3 Mbps will not be available. Max transmit power of legacy 1 Mbps set the basic rate max transmit power. Max transmit power of legacy 2 Mbps set the EDR 2 megabits per second max transmit power. Max transmit power of legacy 3 Mbps set the EDR 3 megabits per second max transmit power. Max transmit power of LE 1 megabit per second and LE coded set the BLE 1 megabit per second or LE coded max transmit power. Max transmit power of LE 2 Mbps set the BLE 2 megabits per second max transmit power. Max Zigbee transmit power set the Zigbee max transmit power. The availability of this functions page depends on the chip. If the chip supports Zigbee, the tool will display this page. Before using Zigbee test, it is best to click the Zigbee Mac Init button. If user clicks the HCI reset button, and must click the Zigbee Mac Init button again. Zigbee MP transmit, used to test the error vector magnitude, EVM, and mask emissions. The steps are as follows. 1. Choose MP transmit. 2. Choose channel. 3. Choose transmit gain. 4. Choose payload length. 5. Set transmit packet count. 0 means infinity. 6. Click Start button and start to test. 7. After testing, click Stop button. Zigbee PHY transmit 01, modulation used to test output power, frequency offset. Setting up according to the steps in the figure above and click Start button, and after testing, click the Stop button. Zigbee receive test, usually used to test PER. After setting up according to the steps in the figure above, click Start button, and the received messages will be displayed in the green box. If the serial port can be opened, but there are some failed information in the message box, such as device opened successfully, but no MP function or patch, it is likely that the RF test patch has not been burned. Thank you for your listening.